Now let's take one example to demonstrate forward selection algorithm. So here uh, let's let's look into a step-by-step procedure for using forward selection to identify critical sensor readings or operational parameters for failure prediction in predictive maintenance. So that's what feature selection in predictive maintenance using forward selection algorithm. So let's begin with the step one. So step one is to load the data and import libraries, and let's do this. Let's load the text data into a suitable data structures, which is data frame. Then uh, respective libraries, NumPy, pandas, and everything, whatever is required. So, and the most important library that we have to call up here is mlx mlx dot feature selection, and from there we have to import sequential feature selector. Okay, let's look into that now. So this is forward selection. Import numpy as np, then pandas as pd, then the most important one, logistic regression, because it's kind of classification algorithm. So sklearn library linear model package and logistic regression module has been called. Then sklearn and metrics is the package, and accuracy score is the model from it. Then model selection, train test split. Train test split is the module that we have called, and the most important one is MLX10 library and feature selection package and sequential feature selector. Sequential feature selector is the very important one in this. So in addition to that, we will be loading the data set using pandas function, which is read CSV, read underscore CSV, and a respective file name has been given. Let me execute it and let's see what is uh, the data that our table consists of. So this data frame consists of the columns that you see on the screen. These are the various features. You see ambient temperature and degree Celsius, which is between 1229 to various ambient temperatures that we got. Then we have vibrations per second square, and pressure in bars. Then cooling temperatures, it's around this, and speed. Okay, the speed is varying from 18 to 115, and stress 7332, strain units, torque 475 304424491423. That's fine, that's a good one. Angular momentum, torque in Newton per meter, and we have angular moment kg meter square per second. That's 450 to 274.24, and force in newtons, and okay, that's it. Okay, so this is what is our data set. Now let's move on to the step 2. Step 2 is to define a failure indicator. Introduce a failure indicator variable that represents whether the machinery experienced a failure during a specific time period. This variable will serve as the target variable for failure prediction. So that's what we're gonna do. So now we will be introducing a target variable. So let's do that. So now let's define the failure indicator variable. So TF of and here I am gonna giving the failure as a new variable to that, and what it's gonna do, it's a random choice between it's a 0 comma 1, and that's it. It will be in between 0 comma 1 because that's what is our target variable. And now let's see that variable, and if you see here we got the failure. So failure, and you have clearly you can see that. So 0 1 0 1 0 1 0 1, and this is our target variable failure, and remaining all other features are fundamentally they are features. Okay, remaining all columns are features, and failure is our target variable. Next, it's time to do feature engineering. Feature engineering extract relevant features from the sensor data that may be indicative of failure. These could include statistical measures, mean, standard deviation, etc. of sensor readings, temporal features, or any other domain specific features that are known to be important. So then split the data. Now let's split the data set into training and testing subsets. The training subset will be used for feature selection and model training, while the testing subset will be used for evaluating the performance of the selected features and the final predictive model. And that's what we're gonna do now. So let's get into the Jupyter notebook and let's do the train test split. To do the train test split, we need to call up the respective module. So from SK learn model selection, import train test split. Okay. Yeah. So now we have X train, X test, Y train, Y test. So this is total four reference variable names will be given. One is capital X, capital X train, capital X test, Y train, and Y test. Okay, as usual, train test split. This is the class we will be. This is the class we will be calling up. So inside that you have to give the respective data set. So basically, other than because we want to keep this failure asset, so drop failure from our data frame and then you put it a separate one. So here the first argument will take up or else you can simply do it in another way. You can just call up this as just define the variables, just x, these are our features, and y is equal to df. Yeah, x comma y, and here it is. Okay, so that's what the two arguments were given. The train test split is gonna take mainly two arguments, that's capital X and then small y. Then test size, this is also very important because we are going for the random sampling, so we have to give test set. Test size I have gone with 0.2, so 20% of my whole data was be kept aside for testing, so remaining 80% will be used for the training the model. Then random state, I'm going to go with the 42. Okay, so random state 42 is nothing but the same sample. So whatever sample this time it will be taking, and then the same sample will be persisted, and if you execute the same code again one more time or twice or thrice or four times, the same sample will be will be fetched from it. That's what. So random state is nothing but a seed, a random seed. Okay, a random seed. Whenever you sow a seed, you will get a same kind of result, and here also whenever you call the same random state, you will get the same result. Okay, so that's what the splitting the data into training and testing subsets. Let's move. Now it's time for step 5, which is initialize empty feature. Obviously, that's how it works. So initialize empty feature subset. So uh, a feature subset start with an empty feature subset. Then step 6, perform forward selection. Now it's time to get into the actual action. That's perform forward selection. So implement the forward selection algorithm by iteratively adding one feature at a time to the feature subset. Train a machine learning model using evaluation metrics, example accuracy, precision, recall, F1 score. So these are classification evaluation metrics. So accuracy, precision, recall, and F1 score. And so to apply the forward selection, of course, we have to use a respective model. So because we have to use the metrics, so first I'm gonna instantiate the logistic regression class object, and then after that I will be calling up a sequential feature selection call, and then I will be instantiating that object, and finally I'll be fitting that x train and y train into the sequential feature selection. Okay, let's do the step. So it's time to perform a forward selection that you can see here on the screen. So as usual, first we have to instantiate the logistic regression class object. Then we have taken to perform forward selection, we need to go with the sequential feature selector from the sequential feature selector from the MLX 10 library and feature selection package. So what is sequential feature selector? The sequential feature selector from the MLX 10 library provides a flexible implementation of forward selection. By setting the forward parameter to true, you can perform forward selection using the class. So it iteratively selects the feature one by one based on a given evaluation criteria. Here, in case of classification, basically uh, accuracy or F score or precision, recall. So these are the classification metrics or evaluation metrics or evaluation criterion. So and stops when the specified number of features k is reached. So that's where you have to mention the k features. If you look into this, here the model object is required. That's what the first argument it's going to take, because based on that model argument itself, it can apply the evaluation metrics. Basically, this works on applying the evaluation metrics to the various features, and then it will finally come out with the best subset. Initially begins with no subset, like completely start with one feature, then it will keep on scaling up, and then finally it will come up with the best feature subset. Anyway, so that's the reason our sequential feature selector class object class is gonna take model object as the first argument. Then we have to mention the k features. K features is nothing but the number of features that you wanna give. So number of features here, we want it as now how many features we want to give it. So and stops when the specified number of features. Basically, so this is another stopping criteria. If we reach this amount of features, just stop it there. So here I just mentioned one feature, so that's what I'm gonna get one. Okay, let's move ahead. Okay, then forward is true here. So forward is true means we're gonna do forward selection. Forward is true means we're gonna do forward selection. Then scoring. So which evaluation metric you want to use? Which evaluation metric you want to use? So I'm gonna go with this accuracy here. And finally, CV is equals to 5. So the sequential feature selector class allows you to specify various settings and options for the feature selection process. So, such as the scoring metric, cross validation, and whether to perform floating feature selection. Allowing the feature addition and removal. It also provides additional methods and attributes to access the information about the feature selection process, such as the selected features subset. So k subset feature subset names and scores k underscore score at each step. So overall, the sequential feature selector class in the MLX 10 library provides a convenient and efficient way to perform forward selection and evaluate the importance of the of the features in machine learning tasks. And this is how we begin our forward selection uh, method to do the feature selection. Okay, now let's move ahead to the step 7. Let me get back. So step 7 is to select the best performing feature. So keep track of the performance metric for each feature added to the subset. Select the feature that results in the best model performance. Okay, let's do that. Let's come back. Let's go back to that. Now get the selected features subset. So selected features is equals to list of SFS. So this is the sequential feature selector object reference, and I'll call that object basically, and then I mention the object name, and I will call up an attribute. It's an attribute k underscore feature underscore names. This is an attribute which gonna give the all the selected features names. So if you want to see all the selected features names, let me give selected features. So at this moment only one was selected, which is ambient temperature, degrees Celsius. Okay, so okay, so this is k underscore feature underscore names is the method uh, from uh, sequential feature selector object object. Yeah. Then step 8, repeat the process. Repeat the steps iteratively, adding one feature at a time based on their performance until a desired number of features or stopping criterion is reached. Example, no improvement in performance. So that will be done by the algorithms. You don't need to worry, but just mention it for your sake, for your information. So next, evaluate the final feature subset. So once the iteration process is complete, evaluate the performance of the selected feature subset using the testing data. So calculate the evaluation metrics to assess the predictive capability of the final feature subset. Then let's fit this. So once the selected features has been selected, now it's time to train the model using the selected features. So that's what I'm gonna take the selected features. So here what we got, ambient temperature in degrees Celsius, that's what is our selected features. And so let's fit this data into the model so that the model can be trained on this. So train of selected features and white train. So that's what. So train the model using the selected features is done. Next, let's build the predictive model out of it using the selected feature subset, train a final predictive model on the complete training data set. Use this model to make predictions on new unseen data for failure prediction. So with this, so you'll use by test spread and model dot. You'll use a method from the model, and then you will give it required information to that. So basically selecting the features, and our feature selection predictive maintenance using forward selection has been done till here, and then remaining steps are consequential steps of building a model, and that's not the interest of our slide or our concept here, because here feature selection is our area of interest. Okay, so now the final step is to let me get back. So evaluate the model performance on the testing data. So y test spread model dot predict, and then test score and accuracy score is what we'll be using, and y test and y test spread. So finally, let's print the selected feature. This is just a printing. Here, the selected features has been determined, but here, if you want to print it, and similarly, if you just want to print the accuracy or the performance of that test score, performance of the respective selected feature, that also can be done. So that's what we are doing. So print selected features, and after that use a test accuracy, and this is a test score. So test score has been directly calculated from the accuracy function from the sklearn. So y test and then y test spread, the both the information has been given, and then here you'll get a test accuracy. And let me execute and see what's the response we got. So selected features, ambient temperature in degrees Celsius, and test accuracy is 0.925. That's what we have done here. Only one feature we want. So now let's move ahead, and this time let's see what had happened. So number of okay, this time we got two selected features, which are ambient temperature and then vibration per second square and 0.905. Fantastic. The pretty good amount of test accuracy. Okay, pretty good amount of test accuracy. And overall, let me bring it down to the three and see out of all what are the best three. Best three. What are the best three? Obviously, the top one is ambient temperature, a vibration in per second square, then pressure in bar. So accuracy has started coming down. It's 0.89. Okay, so that's how we do the feature selection using forward selection algorithm.